Greetings, welcome towards the lecture series on design of reinforced concrete structures. In this particular lecture series, we will be discussing on the course content of course name Design of Concrete Structure 1, course code BTCVC 601, proposed by Dr. Babasaheb Ambedkar Technological University Lonere for undergraduate students in BTech Civil Engineering. University has assigned a credit of 3 to this course and also defined examination pattern which includes internal assessment and end semester assessment. Internal assessment is composed of periodic test and mid-semester examination having weightage of 40 marks, whereas end semester examination is having a weightage of 60 marks. The entire syllabus content has been divided into 6 units. Unit 1, basic aspect of structural design. Unit 2, design of beams and slabs with reference to working stress method. Unit 3, design of columns, footing and staircase in reference to WSM, working stress method. Unit 4, introduction to the limit state approach. Unit 5, limit state of collapse, Flexure, and Unit 6, limit state of collapse, shear and bond. To prepare this lecture content, I have referred some books which has been recommended here. Limit State Theory and Design of Reinforced Concrete Structure by Shah and Karve, Structure Publication, Pune, India. Reinforced Concrete Design Volume 1 and 2 by Arun Kumar Jain, Ashok Kumar Jain and Punmya BC by Lakshmi Publication, Pune. In addition to this, we are going to refer some Indian Standard Course IS 456-2000 for limit state method, IS 456-1978 for working stress method, and SP16 a design aid for reinforced concrete. So to begin with, here we'll try to understand what is a structural engineering. Structural engineering is a subdomain of civil engineering wherein the structural components are designed and configured in context to the structural action against design load to achieve economy and safety for both structure and life. As we know that structures are subjected to various loadings and their combination. Due to this loading and combination, there are the forces and stresses develop in the member, and we call it as a demand on the member. To mitigate this demand, one have to propose a suitable cross section which is capable to resist this demand. The structural engineer tries to provide a optimum cross section, thereby it's able to carry the loads, also achieve the economy in the design, in the construction part. So structural engineering is nothing but optimization of the section and assessing its safety. Let us try to classify the types of structure here. The structures are classified based on material used, like mud made structure, stone made structure, brick masonry structure, plain concrete structure, timber structure, reinforced concrete structure, pre-stressed concrete structure, steel structures, and composite structure. Mud made, stone made, brick masonry, and plain concrete structures, they are having good capacity towards the compressive load, but they are weak in tensile against the tensile forces. In case of timber structure, they are good for tensile stresses, but they are having shortfall related to the concrete. Means what? Some structures are going to have enough capability towards the compressive stresses, and some are having enough capability to tensile stresses. In an interest to add this to a single material, there is being a composite material defined, which is said to be reinforced concrete structure, where reinforcing bars are being embedded in the concrete so that the tensile strength of the concrete gets improved. Then we call it as a reinforced concrete element. With the advancement in structural engineering and knowledge about the material characteristics, people have started to develop a material with higher strength and higher capability to resist the forces. We are going to use high strength steel, which is prepared by using bundle of wires replacing the single steel bar, and such a steel may have initial compression which will improve the compressive strength of the concrete. Such a section we are going to call as a pre-stressed concrete section. As we know, the rolled steel section or mild steel section are capable to carry more loads in compression and tension. So steel is being an alternative material for heavy loaded structure. But when we use for light loaded structure, it becomes uneconomical due to the cost of construction. Sometimes we have to go with a composite type of combination where we can encase the steel under the concrete, thereby improving its fire resistance and additive properties to that. The such sections are called as a composite section. Based on the dimension, the structures are further classified as a one-dimensional structure, two-dimensional structure, and three-dimensional structure. The structure which is idealized by a single dimension is called as a one-dimensional structure. For example, bars and rods, where we neglect the cross-section area and we concentrate over the length of the member, and we assume that the forces and deformation are being concentric along the longitudinal axis. Such elements are called as a one-dimensional element. In case of two-dimensional element, the effect of the stresses and forces along one of the dimension is neglected. For example, in planar structure, the effect of the forces along the thickness can be neglected. Thereby, we are going to call it as idealize it as a two-dimensional structure. Example: slabs, curved beams, domes, retaining walls, hewn pipes. In case of three-dimensional structure, we are going to have equal weightages of all three dimensions towards the contribution of the loadings. For example, columns and footings. Based on the way they carry the loads, the structures are further classified as beams, trusses, arches, cables, thin plates, plain grids, thin shells. The names are assigned with reference to the action they play. Beams are said to be a member which resists the load normal to its load neutral axis, thereby capable to resist the bending and shearing action. Whereas trusses are said to be a member which are axially compression or axially tensile load members. Their stresses are concentrated along their longitudinal axis. Arches are the structures which are subjected to flexure as well as shear. Cables are the members which carries only the tensile forces. Thin plates, these are the planar structure which are subjected to the bending and shear, and sometimes if corners has been held, then they are subjected to the twist also. Plain grids is a skeletal arrangement of the planar geometries which are capable to resist the twisting force, bending force, and the shear force. Thin shells, these are the curved elements which are having thickness smaller compared to the planar geometry, and curvature is also there. Due to this, there are development of meridional and circumferential stresses, and these members are subjected to your flexure as well as shear. Now, if we talk about the transformation of the loads, that is based on the load path, the structures can be classified as a load-bearing structure, frame structure, and hybrid structures. In case of load bearing, the load is transferred with the help of bearing of the structural members, like slabs bears on the walls bears on the footing, and footing bears on the soil. Such an action is called as a load bearing structure. Whereas in case of frame structure, we have predefined skeletal, where the members are interconnected and they have the collective actions of the transfer of force, like slab transfer the force to beam, beam transfer the force to column through reaction, and column transfer the force to the footing, and footing transfer the loads to the soil. Means there is a skeletal systematic flow of the forces. In some cases, we have to use composite of these two, that is partially load bearing and partially framed one. Then we call it as a hybrid type of structure. So we are dealing with a subject known as a design of reinforced concrete structure. Let's try to understand basic content of this material, that is concrete. What is the concrete? Concrete is a mechanized mixture of cement, fine aggregate, coarse aggregate, and water in a certain proportion, which results in a matrix that hardens, cures over the time, and gains its design strength. The flow chart, which has been shown in a pictorial format below, shows about the formation of a concrete. Concrete is a mixture of ingredient in proper proportion, which is very workable at the time of preparation, and it hardens as the time elapses, and during the hardening process it gains the strength. That's why we can say it gains the strength over the time. What is a plain cement concrete? Plain cement concrete is a mixture of cement, fine aggregate, and coarse aggregate without the reinforcing steel bars, or reinforcement steel bars. So in absence of the tensile carrying elements, we call the concrete as a plain cement concrete. When we add reinforcing bar to this, what happens? This reinforcing bar increases the tensile carrying capability of the concrete section and it provides additional strength, thereby make it suitable material for the construction industry. Reinforced concrete is a composite material commonly used for the building and civil infrastructure, in which reinforcing steel bars are embedded in the concrete to improve the tensile strength and ductility. Besides improving the compressive strength, it also adds to the ductility deformation capability of the section. Let's go towards the understanding of the advantage of reinforced concrete structures. Very first one is the strength. As already I stated, reinforcing bars when added to the concrete improves the tensile strength capability and also ductility. That's why it makes it as a suitable material to carry the loads. Similarly, we have seen the advancement in the material strength and the knowledge of the material characteristics has led to the development of high strength concrete and high strength steel. Thereby, the composite is going to prepare the high strength reinforced concrete section. Economical. The second property, economical, deals with the preparation cost. In preparation of concrete, we use the raw material which are locally available. It includes river sand, aggregates which are obtained from stone quarry, and cement and water. This material have a reasonably low cost, thereby make the cost of construction as a lower one and make entire construction as an economical one. Versatility. In its fresh state, concrete is able to get flow, it's able to get compact, it is able to get leveled by its own. Thereby we can have molding of a concrete in a desired shape, and after gaining the strength it becomes a hard rock of a required strength, and it becomes an alternative for architectural view also. So the versatility of the concrete can be traced with reference to the mode of the construction of that concrete element. Durability. Since the material which we use in the construction of your concrete element are locally available, they are having good strength against the environmental effect, thereby they increase the durability of the concrete. They show less reactivity towards the atmospheric actions. Fire resistance. Since the material used in the concrete, they are repellent to the thermal changes, thereby they are not easily being burned or catch fire, thereby making the structure as a fire resistance up to certain limit. Due to addition of the steel, there is an improvement in the deformation capability of the concrete, thereby we can say concrete material or ductile material also. Easy of construction means it can be casted and transported easily. It's an initial stage, it is workable. That's why it can be placed in any shape, any mold, any form work. That's why we can say it's easy in construction. Besides this, concrete has certain disadvantages. This disadvantage is that it is weak in tension. That's why it has a limited application in tension dominated structures. Since it gains a strength in a stage-wise pattern, it requires or demands the property quality check at interval of times, and thereby have a skilled labor or a skilled monitoration involved in it. It requires a special attention towards the environmental impact, as we are going to use reinforcing bar. When they are subjected to the environmental exposure, they are subjected to the deterioration and corrosion. So we have to take a special care for the effective covers, and that has made limitation towards the application of this section towards a severe exposures. In case of mass concreting, the cement liberate high amount of hydration heat, thereby impacts on the strength of the concrete. Also, the cement liberates the high amount of carbon dioxide, thereby it makes it as a not environmentally friendly materials. This is going to prepare harm to the environment due to release of carbon dioxide.